Welcome back to Least Squares, Regression Lines, and Plots. This is part 2. You can get to part 1 down below. I'm Mr. Hayes of Hayes' World of Math. And so what we're going to do is we're going to formalize what we did, what we discovered about least squares, regression lines, and residual plots. And so this is going to break down into 2 parts. Pretty much split it down the middle. Number 1, make sure we're on the screen here. So number 1, ooh, that's ugly. So we've got least squares regression line. And technically what that actually does is it takes the residuals from the line and squares the residuals and figures out the sum of that, and then sees which one has the small, hence the phrase least squares regression line. And so that's actually the full definition of it. So it's the line, with the smallest sum of the residual squared. And this is usually where your stats teacher will regale you with about how when they were in college they had to do it all by hand, blah, 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 blah. And it's all true, but most of it's true, I think, if they're over 30 or 35. For number 2, you've got your residual plot. Let's try printing here. Maybe that'll work out better. So you've got that. We're going to have our residuals here. Positive and negative. Zeros in the middle. And if you get residuals that are kind of all over the place, and so this is your x-axis down here. That's your explanatory variable. This is good plot. Bad plot has a pattern. So this is bad. And before you in the back ask, yeah, if this was reversed, it would still be bad. Okay. So we want the residual plot to show a random scatter. There's no pattern. So we want residual plots to show a random scatter with no leftover pattern. Yay. Okay. So this is the point. Run through this, check your understanding. So hit pause about now, and then we'll go ahead and check the answers. Again, what you're doing is 9th grade students at Webb High School going on a backpacking trip. Students are divided into hiking groups by size of 8 by selecting names from a hat. Before leaving, students and their backpacks are weighed. Data's here from a hiking group. What else would you do with a bunch of 8th graders, right? All right, so pause it, come up with the answers. We'll see you in a minute. So what you got here is you got to calculate out all of this. Now, I've already got the residual plots written down here. To calculate this out, remember, you're going to go over here, and you're going to put in list 1 and list 2, x, y. When you get done with that, we quit out. You're going to go back into stat, go over to calculate, and you're going to pick linear regression. You can arrow down. Remember, you can also press the number 8. If you want to store it in y1s, you can do it. That's fine. So then when you go down to calculate it out, there's your answer. So for us, our I just turned it off. That's what type of goofball I am. Let's see. All right. So this is going to turn out to be y hat. Remember, because that tells you it's a prediction. The little hat means, we're just thinking that that's what this is going to be, is equal to 16 point, and we're 3 or 4 decimal places is good. Plus, and let's see, 0.0908x. Couple reminders. Put yourself some context here. So we are going to say that this here is backpack weight, the prediction, is equal to 16.2649. What would that be anyway? What's your y-intercept in this case? Plus 0.0908 body weight. That'd be the weight of the backpack initially, before anybody else got on it, and then over here would be the rest of it. So if you had a scout or an 8th grader who weighed nothing, their backpack would be 16.3 pounds. So now your residual looks like this. Now notice here it's a little spread out, but the one thing that you also do have to be careful about this is, as I see people will do this, they do it too fast and they put the residuals in the same order as they have up here. Make sure that, notice here your X values are all different, so be careful of that. So we've got it all here, and you kind of get, actually let me use a different color here. What haven't I used recently? Yeah, let's do pink. So you kind of get this up and back down feel. Now, I know it's not perfect, okay, but what is? But you still have it. You're starting low, it's going up, and then it's coming back low. And so because of that, do you really have a good residual plot here? And the answer is no. So you would say something to the effect of, since there is a negative, positive, negative, pattern, the linear model is not appropriate. Ta-da, you're done. Okay, so good to see you. Make sure you drop a like, a subscribe if you like what you're seeing so you can see more. I'm going to try to get on a little bit more consistent posting schedule here of trying to set them up so that maybe like 1 drops a day after I get done with chapter 3. So with that being said, see you soon. When you miss the stop button.